Hello and welcome to day 3 of sequences and series. The first 2 days we've been looking at series, geometric and arithmetic. Remember, arithmetic is adding or subtracting, geometric is multiplying or dividing. Arithmetic is a linear function, geometric is an exponential function. What we're going to look at today is series. Series is the idea of adding up all the terms in a sequence. So a sequence is just the numbers that deal with each term. So the list of numbers. Series is adding them all up. We're going to skip this page right here. Skip this page, and we're going to go right to page 10 in the middle and start at sum of an arithmetic series. We're going to finish page 9 in class. So in class we will talk about why this is the case, but for right now we're going to just look at how do you find the sum of an arithmetic series. The idea that we can also write here is the sum, we always say S of n, of the number of terms n. So n is the number of terms. The first term plus the last term being added together, all divided by 2. So this is just another way you can write it. But n, number of terms. This is our first term. And this is our last term. This is something that you should know and it should become very familiar with. One of the issues that you're going to have is that this is what we usually need to find. So again, let's talk about what is our arithmetic. How do we find a certain term of our arithmetic sequence? A sub n equals our a sub 1 plus d times n minus 1. N being the number of terms, d being the common difference, and a1 being our first term. So here we go, right into exercise number 3. Which of the following is the sum of the first 100 natural numbers? Show the process. So we have n. N equals 100. We have our first term. We know a1 equals 1 because we got to remember what natural numbers are. Natural numbers are the counting numbers starting at 1 going all the way up. So if we know that these are just the counting numbers going all the way up, we know that our last term, a100, if a1 is 1, we know that a100, if we count 1, 2, 3, 4 all the way up, will be 100. So in this case, we didn't need to use a formula to find the last term. So we're just going to use this, S sub 100, the sum of the first 100 terms of 100 times 1 plus 100, all over 2. If we do this out, that's 101 times 100 will give us 10,100 divided by 2, and that will give us 5,050. So therefore, choice 4. Again, number of terms, first term, last term divided by 2. And we will again discuss this, why that is in class. So let's look at this one. Sum of the 16 terms. This is nice. It gave you how many terms we had. Also gives you your first and last term. So this isn't bad at all. The sum of 16 terms equals number of terms 16, first term plus last term divided by 2. Well, we're going to get 16 times 40 divided by 2. If you didn't have a calculator, 40 divided by 2 is 20, so we're going to get 20 times 16. And we know that that will give us 320. So moving on to a more difficult one now. So this one was easy because we are given the number of terms and the first and last term. You just plug it into the formula. For B, the first term, so we can write down what we're given, -8. The difference is 6, and that the n is 20. What are we not given? We're not given what a sub 20 is. So we need to find it. And there's not a ton of room here, but what you would do is you go to the side and you say, okay, I need to find the 20th term. Well, a sub 20 equals the first term plus the difference times 20 minus 1. Again, you gotta memorize that formula or else this unit's going to be really difficult for you. So we get -8 plus 6 times 19, and we will get 106. be A20. So now to find our actual sum, we're going to do sum of 20 equals our 20 terms, first term plus the last term divided by 2. We know that's going to be 98, and we know 20 divided by 2 is 10. So we're going to get 980 to be the sum of the first 20 terms of that series. Okay, C, a little different. So what we're trying to do here in exercise number 4 is give you all the examples that you could have. In C, we're actually given the last term, A12 equals negative 29. We're given the difference to be negative 3. And we know that the number of terms, if the last term is A12, we know that number of terms is 12. What are we looking for? We're looking for A1. Well, how do we find it again? You go off to the side and you find it. We know that A12 equals A1 plus D times n minus 1. Well, we know what D is, negative 3. We know what n is, 12. We're trying to find A1, and we know what A12 is, 29. If you do that math out, we're going to get 11 times negative 3 is negative 33. Add it over to this side. We know that A1 equals that. And we're going to get negative 29 plus 33 to be 4. And so we know that A1 equals 4. Now, that's just the side work to get us on how to get the sum. The sum of the first 12 terms is number of terms 12 times A1, which we just said was 4, plus the last term, negative 29, divided by 2. And this is going to give us 6 times negative 25, and that's going to give us negative 150. So our sum of that entire series was negative 150. You know I'm moving fast. Pause it, repeat it if you need to. Pause the video and look at what we've done if you have to. There's no issue in doing that. It's the beauty of doing videos. D, the last one, the sum of these terms. Well, the nice thing is that we have our first term, 5. We also have our last term, 77. What we don't know is how many terms there were. And so we've got to figure this out. Well, we know that to go from 5 to 8 is 3, 8 to 11 is 3. And so what we're going to do is plug in to the formula 77 equals 5 plus 3 times n minus 1. Our last term equals our first term plus the difference times n minus 1. Well, subtract the 5 over, you get 72 equals 3n minus 3. Add the 3 over, you get 75 to equal 3n. And so n equals 25. And I know I did that fast. Again, pause it if you need to. What we're going to do now is go into our sum. Our sum of our first 25 terms equals 25 times our first term plus our last term, all divided by 2. So 25 times 82 divided by 2, that's 25 divided by 2. 25 times 41, and that gives us 1,025 as our answer. So all 4 different steps right there to figure out how to find the sum of an arithmetic series. So let's look at this last exercise before moving on. Kirk has set up a college savings account. If Kirk deposits $100 per month and increases the deposits by $10 per month, how much will he have after 10 years? I want you to pause it and set it up. First term, number of terms, last term. Do the work if you need to. When you unpause it, I'll have the answer and hopefully you've got it correct. Pause it. So we have $100 per month, increasing the amount he deposits by $10 per month each month. How much will he have after 10 years? Well, the thing you have to remember is 10 times 12 will be the total number of deposits. So there's the work. Pause it if you need to. I have it all out there. We're going to move right on to the sum of an infinite geometric series. So infinite geometric series is the adding up of all the geometric sequences. This being, I like to use this equation right here. First term, your common ratio, and your nth term. Not much to it, just plug in and go. So, which of the following represents the sum of a geometric series with 8 terms? That's our n, whose first term a1, and whose r value is 4. And so when we write it out, sum of 8 equals our first term, 3 parentheses, 1 minus 4 to the n, 8, over 1 minus r. And in your calculators, you need to be doing y equals, or alpha y equals enter to make sure that you have this correct with parentheses. And yes, it should be 4 there. Notice that. When you put that in your calculator, you get choice 4, 65,535. What I would like you guys to do right now is just try 4. See what you can get, knowing that a1 or an equals a1r to the n minus 1. See what you got. Pause it and try it. Now, if you're stuck, I understand why. You need a calculator to be able to figure this out. So when you got down to 128, since you divided 768 by 6, you can go into y equals, type in 2 to the n minus 1, and then go to your table and figure out which n value it is to give you 128. And you'll notice that n is 8. And so therefore, you're going to do 6 parentheses 1 minus 2 to the 8 divided by 1 minus 2, and you should get 1,530. And we'll finish off with example 5. Maria places $500 at the beginning of each year into an account that earns 5% interest compounded annually. Maria would like to determine how much money is in her account after she has made her $500 deposit at the end of 10 years. So we're going to determine a formula for the amount that A of t grows after t years. Well, we've talked about this before. Our formula is to be A of t equals, how much money did she begin with? 500 times 1 plus 0.05. Where's the 0.05 coming from? But 5%. To the t. That's A. Part B asks you which one will be worth more, the $500 that she invested in the first year or the fourth year. I hope you guys all understand that interest compounds. The faster you get it in, the more money you get back. So it's definitely the one after 10 years will have more money because it's been able to gain more interest. It's been there a longer time in the bank. So C, based on B, write a geometric sum representing the amount of money in Maria's account after 10 years. So you're adding each one of these. You're adding 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All of those are going to be the amounts we added up. So it's, again, the geometric series. We have the sum of 10 equals A1, which was 500, times 1 minus our R, 1.05. It's what we're increasing at, raised to the 10, the n, divided by 1 minus 1.05, 1 minus R. And after we get that, our answer will be $6,288.95. So pretty good. If you start with $500, increase it by $10, or earning 5% interest every year, you'll be left with $6,288.95. And we will finish up what we did not do in class. Have a good day, and I'll see you in class. Bye.